Alright, so continuing where we were in class today, those of you who are not going to be here tomorrow, the only exponent we have in here is a 3, which is odd, and the 5 here is positive. So that means that at the left side of my graph, which means x is at negative infinity, we are going to be down, which means y is going to be at negative infinity. And at the right part of our graph, which means x is going to be big, we went up, which means y is going to go to infinity. So these are the things that are the answers to our question. So when we take a look at the next problem, here's my exponent of 3, which once again is odd, and the 5 is negative, which means on the left side we actually are going up, and on the right side we're going down. And just for the sake of argument, for this next problem, which is not on your graph, that's even, and that's higher than 3, and this is negative. So both on the left side we go down, and on the right side we go down. Alright, so next we're going to talk about increasing and decreasing. Anytime a graph looks like this, where it goes down as we look from left to right, because we read a graph like we read a book, it's decreasing, and over here we are increasing. So if we have, in example 3, f of x equals x squared minus 7, and we're going to do a rough sketch of what you'll see on your calculator. We are looking for where this increases and where this decreases. So this graph starts out decreasing, because here I'm going down, I'm going down, I'm going down until I get to right about here, which is at x is 0. And then after 0, we are going up, so we're increasing when x is bigger than 0. Remember, we're only going to be looking at the x values, not the y values. Alright, the next graph we have y equals negative 1 over x. And if I graph this in my graphing calculator, I get a graph that looks like this. Well, my graph starts out increasing when x is less than 0. Then there's a discontinuity at 0, and then I'm increasing again when x is bigger than 0. So this graph is increasing both when x is less than 0 and when x is greater than 0. So we have nowhere where this graph is decreasing, and we don't worry about 0 because that's a discontinuity. Alright, our last graph is y equals 5x cubed minus plus x squared minus x plus 4. And to get a better look, I kind of zoomed in on a section, and it sort of looks like this. And so we're going to start out increasing until we get to here. And I need to know what this point right here is, and this point is what we refer to as a maximum. So in my calculator, I'm going to go to second trace, and number 4 is maximum. And then after that, it says left bound, so I'm going to pick a point over to the left and hit enter. And then then it says right bound, and so I pick a point to the right and I hit enter. And then I hit enter a third time, and it tells me that this point is at negative 0.333, comma 4.25. So really all I'm worried about is this. So when x is less than negative 0.333, I'm increasing. And then it's going to decrease for a while. And it starts out decreasing at that same 0.333. And then this time I need to find not a maximum, but a minimum. So this time, instead of second trace 4, which was maximum, I'm going to go second trace 3, which is a minimum. And so we pick a point to the left, pick a point to the right, and then we hit enter a third time, and we get the fact that this is at 0.2, comma 3.88. Now remember, I'm only worried about the x value, so that means it was decreasing in between 0.333 and 0.2. After 0.2, it goes up the rest of the way, so once again it increases when x is greater than 0.2. So here's where it increases. It starts out increasing and it ends up increasing, and then for the decreasing was what happened in the middle. And that's what we're doing for 3-5 day 2.